So as I said last time, syllogisms with conditionals, which we'll start talking about in this lecture, are harder, right? And what do I mean by a conditional? We've already seen it with our little argument about Mustard and Scarlet. You know, if Mustard committed the murder, he used a gun. That is a conditional. If it snows, TCC will cancel class. If you study hard, you will get an A, right? Conditional or hypothetical statements. You're saying, well, if this one thing happens, or if this one thing is true, the other will be as well. Now, these are super important, but they're tricky in several ways. For one thing, there are several different valid forms of argument that use them. With disjunctive statements, there's really only one, right? This argument by elimination. A or B, not B, so A. A or B, not A, so B, right? That's really the only thing you can do, at least with the inclusive or, right? There are actually several valid forms of argument that use conditional or hypothetical statements, and there are several forms of invalid argument or fallacies involving conditionals. A fallacy being an argument that is not valid, but is easy to mistake for a valid argument. So the first valid form of argument using a conditional, an if-then statement, is called modus ponens. Now, remember, as I said, for the or statements and the if-then statements, there's not really a great way of representing these with a diagram. There are ways of doing it, but they're way more complicated than the Venn diagrams. So it's easiest, especially at this stage, I think, just to learn the rules, right? Memorize these valid forms of argument, know that if it's valid, it works. Memorize these fallacies, know if it has this form, it doesn't work, it's a fallacy. Okay. So here are a couple arguments that use modus ponens, which is a valid form of argument. If it snows tonight, TCC will cancel classes tomorrow. It is snowing tonight, TCC will cancel classes tomorrow. If Scarlett committed the murder, it was done with a pistol. She did it, so it was done with a pistol. If A, then B, A, so B. Modus ponens is a valid form of argument. Any argument that uses this form, at least this step, is valid. If A, then B, A, so B. The sort of flip side to modus ponens and another form of valid argument is called modus tollens. Here's some arguments that use this. If Joe applied himself, he would make all A's. He didn't make all A's, therefore he didn't apply himself. Now this one's a little trickier, but think about it. Let's say we know that this guy's smart. Let's say that it is true that if he applied himself, he would get all A's. He doesn't get all A's. Well, if that's, if it's true that if he did apply himself, he would, and he didn't, then we know he didn't apply himself. If it rained last night, the ground would be wet. The ground is not wet, so it didn't rain, right? I know that whenever it rains, the ground is wet. If I go out and I wonder, did it rain last night? And the ground is bone dry. That's like, well, it didn't. Or, and this is a case that was in the news a lot, there were these experimental results saying neutrinos were somehow traveling faster than light. Well, they can't do that, so the results had to be false, right? If the results are correct, neutrinos are going faster than light, but neutrinos can't do that, so the results aren't correct. I'm using ergo here. It's a fancy, pretentious word for therefore or so. A little variety, right? Also, might as well learn some pretentious words. Like college is the place for that, right? Among other things. If A, then B, not B, so not A. You know that whenever you have A, you're also going to get B, so you know that if you don't have B, you don't have A. Whenever it rains, ground is going to be wet. Well, if the ground's not wet, it couldn't have rained. You know, the results are correct. Neutrinos are going faster than light. We know they can't do that, so the results can't be correct. This guy really is smart enough to get all A's if he works hard. If he doesn't get all A's, we know he's not working hard, right? If A, then B, not B, so not A. Now, one thing, and we've already talked about this, is that if A, then B, and if not A, then not B are logically equivalent statements. Logically equivalent just means if one is true, the other is true as well, and whenever one is false, the other is also false. Whenever if A, then B is true, if not A, then not B will also be true. And whenever it's false, this one will also be false. So, if you have if A, then B, with logically equivalent statements, you can always replace one with the other. If you have if A, then B, you could always replace it. You're allowed to replace it with if not A, then not B. We'll talk a bit more about logical equivalence, but these are statements that are. Remember, we've already talked about this a bit. No A or B is logically equivalent to no B or A, right? And, you can replace no A or B with no B or A because the statements mean the same thing. The Venn diagrams look exactly alike. Remember, the same held for the sum statements. Sum A or B is exactly logically equivalent to sum B or A. The Venn diagram for those two is going to look alike. On the other hand, all A or B is not logically equivalent to all B or A. Those look different, right? Some A or not B, different from some B or not A. We've already talked about logical equivalence. Know that this holds with the conditional as well. You can't really use the Venn diagram to think about it as neatly, but it does hold here. Now, we'll come back to this idea of logical equivalence because it is very important. But for the time being, I want to talk about one of the things that makes conditionals tricky is that there are two fallacies involving conditionals. Fallacy is a form of argument that looks like it's valid, but it is not. And the two fallacies are denying the antecedent and affirming the consequent. Now, look, I don't really care all that much that you're able to pin the proper name on these. That would be nice, right? What's really important, though, is that you see that these are fallacies, that these are not valid forms of argument, and that you understand why. Remember, for an argument to be valid, whenever the premises are true, the conclusion has to be true as well. These are not valid because there are ways for the premises to be true and the conclusion false. If it snows, so here is an example of denying the antecedent. If it snows, TCC will cancel class tomorrow. It will not snow, so TCC will not cancel class tomorrow. Now imagine that we are in, I forget what hurricane season is. My wife is very afraid of hurricanes. She always remembers. I think it's October, September. I think it's August to October. Let's say September. Let's say it's September. All right. And there's a hurricane headed up the coast. It is true that if it snows, TCC will cancel class tomorrow, right? Look, if we're being really picky, maybe we have to say it snows and it sticks. But if it snows, if it really snows and it sticks, we will cancel class. Always do. Now, if it's September, it's also true that it's not going to snow tomorrow, right? Not going to happen, right? Does not snow in Hampton Roads in September. It is true, whenever it snows, we cancel class. It is also true it will not snow if we're in September. But imagine a case where there's a hurricane, it's going to hit tomorrow and hit us dead on, they think. Well, it's true, whenever it snows, we'll cancel class. It's also true it won't snow. It may not be true that we will have class, right? I'm going to guess if a hurricane is about to hit us, we are going to cancel class. So this is not valid because there are ways for the two premises to be true. If it snows, we cancel class. It won't snow, and the conclusion false. You know, I guess if you want to be super literal, you could even say something like, if it snows, we will cancel class. It's not going to snow because it's going to be freezing rain. We're going to get an inch of freezing rain. Well, for being literal, it's true that whenever we cancel class, whenever it snows, we cancel class. And it's also true, if you're being literal, if you get an inch of freezing rain, it's not snowing. Nonetheless, the conclusion will be false because if we get an inch of freezing rain, I'm sure we're not having class, right? Or think of this other one. If Steve starts training for a marathon, he will lose weight. Steve won't start training for a marathon, so he will not lose weight. Well, look, there's all kinds of ways for these premises to be true. It might be, it almost certainly is true if you start training for a marathon, you're going to lose weight. Seriously training, right? And it might also be true that Steve is not seriously training for a marathon. But we don't know that he won't lose weight, right? There's a lot of other ways to lose weight. He could start doing some other workout, right? He's like, no, I'm focusing on swimming, or I'm focusing on riding my bike, right? Or maybe instead of a marathon, he's training for a triathlon, biking, swimming, and running, right? He would lose weight in that case. So it could be true, if he starts training for a marathon, he would lose weight. He's not training for a marathon, and it could be false that he won't lose weight, right? Or he might just go on a weight loss drug, right? Or some diet that actually works. Lots of ways to lose weight. Training for a marathon might be one of them. But we don't know from the fact he's not training for a marathon that he won't lose weight. One reason TCC will cancel class is if it snows, but we don't know from the fact that it's not snowing for certain that we will have class because there are other reasons to cancel class. So this is a fallacy. If A, then B, not A, so not B. Denying the antecedent, fallacy. This is not a valid form of argument. Now look, I think one of the reasons this is attractive is that, if we're thinking about inductive reasoning, then, one reason we'll cancel class is snow. It's not snowing. If you know that's true, then the chances we will have class tomorrow have went up, right? In a lot of contexts, they might go up a lot, right? If you're wondering if we're going to cancel class because we might or might not get snow, and lo and behold, it's all rain, then the chances we are going to have class have went way, 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 way up, right? But deductive reasoning, it's not about probabilities, it's about certainty. So even though there is some good inductive reasoning that might look a bit like this, it doesn't work as deductive reasoning. I think this is tempting, because there's inductive reasoning that looks a bit like it, but we are in the realm of deductive reasoning. Deductive reasoning is about certainty. Here's another one. This is called, first one was called denying the antecedent. This one's called affirming the consequent. If Jane buys a new car, she will sell her Kia. she sold her Kia, so she must have gotten a new car, right? This is a fallacy because it could be true if she bought a new car, she would sell the one she has now. And it could be true that she sold the car she has now, but there might be other reasons for doing that. It might be true that if she got a new car, she would sell her old one, and she sold her old one, but maybe she sold her old one because her parents have given her a new car, right? Or she inherited a car from an uncle. Or maybe she's moving to Europe where she doesn't need a car and it's just selling the old one, is not going to have a car at all, right? There are lots of ways you can think of where the premises are true and the conclusion false, so it is not a valid argument. If Bob gets LASIK surgery, he will stop wearing glasses. He stopped wearing glasses, so he got LASIK surgery. Again, there are lots of ways these two premises could be true and the conclusion false. It could be true if he did get LASIK surgery, he would stop wearing his glasses, but maybe he just lost them and doesn't have the money to replace them, right? Or maybe he got contacts. Those are other reasons he might stop wearing his glasses, and those could be true. We don't know from the fact that he would stop wearing them if he got LASIK, and he has stopped wearing them. We don't know that he has, in fact, gotten LASIK. Again, I think people sometimes think these are valid because there is decent inductive reasoning that looks like this, right? But again, we are talking about certainty. If we know that he's wanted LASIK and he stops wearing his glasses, then, the chances he's gotten the surgery have went way up, but we don't know for certain, so it is not valid. This is the form, if A, then B, B, so A. This is a fallacy, affirming the consequent. I don't care so much that you can tack the right name to this or denying the antecedent. Just know when you see them, they are fallacies. They are not valid forms of argument. The final thing, Kelly starts with this. I really wouldn't, but just know hypothetical syllogism, sometimes you can infer something really determinate from conditional statements. You can also just know that some other conditional statement's true. If A, then B, if B, then C. Well, if those are true, then if A, then C. Whenever A is true, B is going to be true. Whenever B is true, C is going to be true. Well, if that's so, whenever A is true, then C will be true as well. If it snows, TCC will cancel classes. If TCC cancels classes, Joe will be happy. So if it snows, Joe will be happy. Note that it also runs the other way. If A, then B. Whenever you have A, you have B. Whenever you have B, you have C. Well, if that's true, if you don't have C, by modus tollens, you don't have B. And if you don't have B, then by modus tollens, you don't have A. So if this is true, if not C, then not A. If Jill gets a job in Boston, she will put her house on the market. If she puts her house on the market, it will be listed on Zillow. Those are both true. And you look on Zillow and you don't see her house. Imagine you're like some of my aunts are just nosy, but you don't want to ask somebody the question because you don't want to seem like you're nosy. Well, she's going to sell her house if she has to move. She has to sell her house, it's going to be on Zillow, but you don't see the house on Zillow, so she's not going to have to move. Or if you don't see it, then you would know that. All right, so that's a lot of material. We will do a lot more practice with it. Conditional statements are tricky. There's just no way around it. But I think like with anything that's tricky, a bit of practice, and they will get much less tricky.